We've dealt with direct variation. We've dealt with inverse variation. Now it's time to talk about joint variation. Joint variation looks something like this. Y equals k times x times z. Or the way we would say that in a sentence is y varies jointly as x and z. So notice the inverse variation is the only one that divides. Both direct and jointly multiply. So inverse divides, the v's stay together, but both jointly and directly multiply. Joint just multiplies more than one. So y varies jointly as x and z. So here's our first example. Y varies jointly as x and z. So our first step is to take that line and write the equation. We get y equals k times x times z. We know we're multiplying because it says jointly. Then they give us one set of numbers, y equals 10, x equals 5, and z equals 4. We'll use this information to solve for k. 5 times 4 is 20, and we can divide both sides by 20, and we'll get that k is equal to 1/2. So we used the first set of numbers they gave us to solve for k. K is equal to 1/2. Now I can write the equation with 1/2 plugged in for k. Once we have found k, we then use the second set of numbers they give us to solve for whatever variable they ask for. In this one they asked us to find x when y is equal to 80 and z is equal to 6. I can simplify 1/2 times 6, that gives me 3, and then divide both sides by 3. And you can leave that as 80 over 3, or if you prefer the decimal, 80 over 3 is equal to 26 2/3. Alright, this example. Y varies jointly as the square of x and z. So I want to go ahead and write this and then talk about how it's worded. Y varies jointly, so I know multiplying, with the square of x, that's the same thing as x squared, and z. Now sometimes I have people ask me, well, shouldn't I be squaring z as well? They have to explicitly tell you to square them both if they want you to square them both. So they would have to say something like y varies jointly as the square of x and the square of z. Or they would say something like y varies jointly as the square of both x and z. So they would have to very clearly and explicitly spell out that both need to be squared if they both need to be squared. Otherwise, you just go off exactly what you see. It says it varies jointly as the square of x, which we have, and z. Then it says y equals 11 when x equals 2, and z equals -4. Sorry, not -14, -4. Make sure you don't forget the squared in that part. So x is being squared, so it's 2 squared. We can simplify the part on the right. 11 equals k times 2 squared is 4, times -4 is -16. And I'll divide both sides by -16 and get that k is equal to a -11 over 16. So the first set of numbers they gave me allowed me to solve for k. So I can rewrite the equation now with k plugged in. Now I can actually solve the problem they asked me to do, which is to find y when x is equal to 3 and z is equal to 9. So if we multiply negative 11 over 16 times 3 squared times 9, we end up with y equaling negative 55.6875. Okay, final example. Y varies jointly with x and z and inversely with w. So this is where you have to remember which word means what. Jointly means we multiply. So I will have y equals k times x times z, because jointly means we multiply. And inversely with w. Inverse means we divide. So we divide by w. So jointly with x and z is why we multiply by x and z. Inversely with w is why we divide by w. So we have a lot of letters. We use the first set of numbers they give us to solve for k. It says when y equals 10, x equals 2, z equals 5, and w equals 3. We'll use this information to solve for k. We get 10 equals k times 10 over 3, because 2 times 5 is 10. Then I'll multiply both sides by 3. I get 30 equals k times 10. Then divide both sides by 10. I get 3 equals k. So now, using that first set of information, I know what k is equal to. I know the constant of variation. It is 3. So I can write the equation as y equals 3 times x times z all over w. Now I can solve the problem they ask, which is to find y when x equals 4, z equals negative 2, and w equals 1. So we can just multiply those numbers out. 3 times 4 is 12, times negative 2 is negative 24. And that concludes joint variation.